Here we're looking at the Phillips Exeter Math 2, page 40, number 8. And the question is just asked, is it possible for the sides of a triangle to be length 23, 19, and 44? And explain. So before we start looking at this, let's look at, well, what are possibilities for the sides of a triangle? So we know that we could have a triangle, for instance, that is a 3, 4, 5 triangle. We know that exists. It's a right triangle. Okay, so we can start thinking of right triangles that exist, and that doesn't help us a whole lot. The question is can we think of some triangles that don't exist? So I mean, obviously we can't have a side that is 0, so we couldn't draw a triangle like this that has side 0. Obviously that wouldn't work. So we couldn't have one that says 0, 1, and say 10. And obviously that's not to scale. So let's think of one that has some numbers other than 0 that don't work. So the question, I guess, would be, could we have one that has sides 1, 1, and 10? So would 1, 1, and 10 work? And of course we could draw it and it won't be to scale. And we can say, oh, there's a 1, 1, and 10 that works. But that's not going to work because this 1 is almost as long as the 10 side. So let's try to make this to scale more. If we did that, we'd end up with a 1 and a 1 there. And we could see that those won't reach in order to make a triangle of size 1, 1, and 10. So then the question becomes, well, what if we extend it? What if I extend this side here, and instead it's of 1, I'll make it 2. We can still see that it won't reach. So naturally the next question is, well, how far can we extend it to when it reaches? Well, I'll go ahead and argue that what if I had think about this one, a 5, a 5, and a 10. Would that reach? And hopefully you're thinking the answer would be no. And the reason is because as I try to touch them, they won't quite touch. And if I start to move them, hinge them downward, they would eventually touch, but they wouldn't touch until they reached this line. And then they would lie right on that line, right? Because 5 plus 5 equals 10. So then the next bigger generalization here is that, well, how big do they have to be? Well, if you get this idea that these two sides that I just had on the 5, 5, and 10, those two sides equal 10. So 5 plus 5, that equals 10. And because it equals 10, they're going to lie right on that line. It should make sense that they would have to be bigger than 10. So I could make one that is length 6, and 6 would work because eventually they would touch, probably down in this region somewhere. You could draw a 6, a 5, and a 10. And because 6 plus 5 is greater than 10, that works. So we can put this into words, and in words it is the two smallest sides, or the two shortest sides. Let's go ahead and just hopefully type this out. We went ahead and typed it out, and it's the sum of the two shortest sides of a triangle must be greater than the third side. So if you think about that, that's why this 3, 4, 5 works, is because 3 plus 4 is greater than 5. That's why that works. So going back to our original question, is it possible to have a triangle with sides 23, 19, and 44? Well, you've got to take 23 plus 19. Is that greater than 44. And of course, we add it up and we get no. 42 is not greater than 44. So the answer would be a big resounding no. We cannot have a triangle of sides 23, 19, and 44.